So with binomial, we have a lot of new notation. So let's have a breakdown of the notation, and then I'll show you how to calculate probabilities using Geogebra. So when we use the binomial model, we should have Bernoulli trials. So again, there should only be two outcomes, success or failure. So we'll have some probability of success and some probability of failure, for which we're going to use little p and little q to represent. Most often they'll tell you what the probability of success is. So to know the probability of failure, you just take 1 minus that value, since they'll be complements of each other. Just like the notation that we used for our discrete random variables, we'll be using this probability of x coming through. And what x will represent in these cases is this number of successes and n trials. So we're going to repeat this process and then say, what's the probability of seeing a certain number of successes, or at least some certain number of successes, or at most, things like that. So something that comes up in this section is ways to define a model. And that's what we're seeing in this notation up here, is if once we realize we have Bernoulli trials and we're looking for probabilities of a certain number of successes, we can define the model for how these probabilities will behave. And what this represents is we have our random variable x, so it's like the number of successes we see, and then that line there in mathematics means is defined by. So what we're saying is our variable x is defined by, it's a binomial model, and then the two pieces that are going to really define our model is the number of trials we're working with and our probability of success. So I'll show you this notation. It's just a way to define the model in shorthand, and it can also kind of help when you get to GeoGebra and lining up your values. In this section, we do have expected value and standard deviation. The formulas go for expected value, which is also a mean. You just take your number of trials times your probability of success. For standard deviation, you take the square root of number of trials times your probability of success times the probability of failure. Now, these values here, they'll also just be given to you already calculated within GeoGebra, which GeoGebra is going to show you a screen like this down below, and you can find your mean and expected value down there. So you can just copy those, or if you want to show your work for calculation, either way works great. All right, so let's look at this model where we're going back to our basketball player, but what we're going to change is our number of trials from what we were looking at. So she's still making 82% of her throws. We're going to have independence, and she's shooting 10 free throws. So what this is telling me in terms of notation is our number of trials is 10. We have this probability of success of 82%, and probability of failure is 1 minus that value, which is a 0.18. So if I needed to define this model, I would know it's binomial because there's only two possibilities. She either makes it or doesn't make it. There's a certain number of trials involved, and we have independence, so that probability isn't changing. So I could say is x, which in this case would represent the number of free throws that she makes, is defined by a binomial model where we have 10 trials and a 0.82 probability of success. Those two pieces there will define how our probabilities spread out. So from here, where we start calculating probabilities, and we can even look at the wording like probability that she makes 5, probability she makes 9 or 10, looking at this probability of seeing a certain number of successes coming through. So there is that formula for binomial. You'll see it in your textbook and elsewhere. It should look something like this, which is just a breakdown of what we calculated in that previous video. But what I would like us to do is don't worry about the formula. If you want to go for it, go for it. It'll do the same thing, but there are certain questions that we'll look at that'll just be too difficult to use that formula with. And there are tools within calculators, or at least some calculators. Microsoft Excel can do this too. So use what methods you're comfortable with. But GeoGebra is the only one that I've really seen that provides a visual with it, which can help some students. So that's the formula, but you are not required to use that for this course. What we're going to focus on is using technology. So let me get you to this screen right here in GeoGebra. So if you're in Geogebra, and what we did before is we went to Geogebra Classic to get to the spreadsheet view, but this is a different side of statistics. This is probability. So we're going to be using this tool right here. So you go to the Geogebra website, then look at more apps, and then go to probability. Now, this will open up a screen with a bell-shaped curve, the normal distribution, which is something we'll be doing in the future. So we will definitely come back to this screen, but this is a normal model and we want the binomial model. So what you'll want to do is there's this drop-down menu on the left-hand side here below the graph. So if you see where the words say normal, what we're going to do is open up that drop-down menu, and you can see all of these possibilities here, and we want binomial. So you'll want to go to that drop-down menu and switch over to binomial model, and then you'll see this, like the main difference is that we're working with discrete outcomes here. So like how it's set up right now is that we can have an outcome of 10, 9, 8. It's not continuous. Whereas with that normal model, what we'll see is a continuous number line where you could land absolutely anywhere, but we'll talk about that in the future. So binomial model, you'll want to switch to this screen right here. Then the first thing, well, that's the first thing you want to do. The second thing you want to do is adjust N and P, so your number of trials and your probability of success. So for us, number of trials is 10, and our probability of success is 0.82. So you can see here is our outcomes. You'll see these half values here, but think about that you can only land at these values that are in the middle. So what this would read as is, here's the chance of her making all 10 free throws, 9 of the free throws, 8 of the free throws, 7, 6, 5, 4, and like out here at 0 would be the probability that she makes none of them, or she misses all 10 free throws. And then the height of the bars match up with the probability. So if she has this 82% chance of success, we expect her to make a lot of the free throws. So that's where you can see the tallest bars here. The highest probabilities are occurring at these higher values, these higher number of successes, because we expect her to be out there. Whereas like 0, 1, and 2, for her to make 0 of them or just 1 or 2, nearly impossible because she's so good. So if I just played with this and switched her to, say she only had a 20% chance of making free throws, let's say she wasn't a very good player, then the probabilities move around. We'd expect her to be at this lower end of not making very many of them, and then like this case of her making all 10 free throws becomes nearly impossible because it's hard for her to do. So that's where I like this visual, is it shows how those probabilities move around and where the likely outcomes are. Now with this, let's just talk about expected value and standard deviation. You can see those values coming through here. And just to give you a breakdown of how those were found is you could see this as, for our case, where we're working with N of 10, P of 0.82, and Q of 0.18. Expected value, that mean was calculated by taking 10 times that probability of success. So that's where 8.2 is coming from. And then that standard deviation, which you can use either notation, this could also be standard deviation of x, either way, is coming from the square root of 10 times 0.82 times 0.18. So if you plug that into a calculator, you'll get that 1.2149. So there's mean and standard deviation. So just to write up some steps we took, first step, change to binomial model in that drop-down menu. Second step, adjust your N and P to match the problem that you're working with, because those will move around and adjust your probabilities. Now, first question that we're asking here, let's see how we can find probabilities using GeoGebra. There's going to be kind of two spots that we look at for probabilities. There's going to be work that we do down here that can calculate probabilities. There's also information on this right-hand side that deals with probabilities. So, for our first question here, if we wanted to find the probability that she makes exactly 5 free throws, what this would look like in our notation is, what's the probability that our random variable is exactly this number 5. Now these probabilities of looking for exactly something, what we can do is look over on this right-hand side. This is listing all of our exactly probabilities. So what we could do for this scenario is just look up where is 5, and that probability will be listed right next to it. So these values for k are the possible outcomes. So like 0 successes, 1 success, 2, 3, 4, and we want this probability that she makes 5 of the free throws, which has a matching probability of 0.0177. So in the background is that formula at work of thinking about number of successes, number of failures, and how many different ways can she make 5 free throws out of 10 tries. But without using that formula, what we can do is just grab the outcome from there. And then we'd have a sentence of there is a 1.77% chance she makes exactly 5 free throws. And you could even say it makes exactly 5 of the 10 free throws. If you want to put that in there, that's even more correct in that we're seeing a certain number of successes out of this overall number of trials. If we wanted this probability she makes exactly 9 or exactly 10, so again, or is our addition rule. So we'll have this probability of making 9 plus this probability of making 10. So what we can do is go over to our table and just look at where's 9 and 10. So to make 9 has a 0.3017 chance, to make 10 has a 0.1374, and we want to add those values together. So with this, it would be a total of 0.4391. So there is a 43.91% chance she makes 9 or 10 free throws. And visually, what's going on here? So with that first question, the probability that she makes 5, what that would be calculating is just the height of this bar here. So that probability there is what's coming through as that 0.0177, which is a low probability. And it's because, again, she's so good, we expect her to be out there on the right-hand side. So we're getting this high probability in part B because we're looking at this probability of 9 or 10. So it's like we're taking that probability there plus that probability there, and that's where we're getting this overall high probability because those are pretty likely outcomes for her. All right. So now let's talk about these wordings that we'll see here of making at most, making at least coming through, and then even between. This wording is going to come through, and we'll want to use a specific function that we're seeing in Geogebra to help out with this. That's this second section that I highlighted down here. And where you're going to start is with these 3 buttons to the left here. This button over here makes a left-sided graph. So this will be the same as less than or equal to, or the wording you'll most likely see is that at most. But if you want less than or equal to, you'll use that button there. This middle button is for any probability dealing with between 2 values. So you'll set a left value and a right value. And then this button on the right-hand side will deal with at least, where you want everything to the right-hand side. So that's when you want more than or equal to. So let's play around with these for our examples. So what's the probability that she makes at most 2? So what we want here is, again, that's giving us our most value. So we want to stop at 2 and have everything below. So this is the same thing as less than or equal to 2. So the button that we want to use here that we're seeing on Geogebra looks like this. It's going to stop on this right-hand side and then take everything to the left. So this is like a left-sided probability. So, and then we want this area that we're taking to end at 2. So let's jump over to Geogebra. So I have my 3 buttons here, and what I'm going to do is switch to this left-sided model. So you can see as if I move this around, it's stopping at where that area stops shading, and then it's including everything to the left. You can even see how it changes on this right-hand side. Like right now, what it's taking is that probability of 8 and everything below. But what I want to do is change this to 2. Now with the binomial model, this dragging function's pretty nice. We won't want to do this with the normal model, and I'll tell you why when we get there. But for binomial, this is pretty great of just moving around. But what you could see is down here, the notation is changing too. If I go to 3, 4, 5, let's say I go to 6, it would be the same thing as if you type in 6 there. So if I know that I want the probability of x less than or equal to, and for us we want 2, you can edit and type that in, and it'll calculate the probability. When you type in here, like if I change that to a 5, notice the probability hasn't changed yet. So if you're on your computer, make sure to hit enter. And usually I just hit enter again just to be sure I really did calculate it, so that the probability adjusts. So 2, which is giving us a probability of 0. So again, she's so skilled, we're not expecting to be out there at all. So with that, you can grab it from over here. That probability is 0. So this would be the equivalent of a 0% chance of her making at most 2 free throws. With at least, this is where it's giving us our least value, and then we want everything above. So we want everything more than or equal to 7. So with this, 7 is going to be the cutoff, and then we want everything to the right. So this will be a right-sided calculation. So the button you'd want to use stops on this left-hand side and then contains everything to the right. So let's go to Geogebra. And what I'm going to do is switch, so it's in left-sided mode, I'm going to change to right-sided. So now where this marker ends, I'm taking the area starting at that spot and everything to the right. Again, you can see how it changes in this exactly mode of what it's adding up. So we want 7 and above. You can see the notation changed here. Again, it looks kind of strange with how they organize it, but it is x is more than or equal to, and this number on the left-hand side. So it's starting there and then everything larger. Again, it's a good habit to have for when we get to the normal model, but typing in that we want this to begin at 7, hit enter, and that'll give us our probability on the right-hand side there. So this probability is a 0.9117. So with this, it's the equivalent of a 91.17% chance she makes at least 7 free throws. And then our third button there is when we want between 2 values. So in terms of notation, what I'd have is I'd have my starting value, so 6 and 8. So I want the probability of being between those 2 values. So in GeoGebra, the button you want to use is that middle one, where it's going to have a lower bound and an upper bound that you're going to set. So in GeoGebra, click that middle value, and now you can see there's 2 buttons that can scroll around. There's a lower value and an upper value, and we want through 6 and 8, though if it's more complicated numbers, you can edit down here. Just make sure your lower bound goes on the left-hand side, and then the upper bound goes on the right-hand side. So it should always go in order, and then just make sure you hit enter to make sure that probability calculates correctly, and that'll be a 0.5395. So that's an overview of GeoGebra and getting probabilities out. And with our participation worksheet, we'll have a lot more practice with this. But in terms of exact values, you want to look at this right-hand side over here. And then when you're looking for a range of values to include, you can use these functions down here. You just want to make sure you get the correct order going. Then the last question here deals with expected value and standard deviation. So mean was that 8.2 that we could have calculated by hand or just grabbing it from GeoGebra, and standard deviation. And with that, in terms of a sentence, and the same as how we have been writing in the past, like the expected. Sorry, let's say we expect her to make about 8 of the free throws. To make about 8 of the free throws. Let's say of the 10 free throws. And on average, this will deviate by about 1 free throw. So in the next videos, I'll show you more examples with these and using GeoGebra and really connecting the wording of the question to how to use GeoGebra to get that answer out.